A paint booth can show an acceptable average airflow and still have an overspray cloud trapped behind the part. That corner recirculation matters. It can reduce finish quality, load one filter zone and leave flammable vapor, mist or combustible residue where the system was expected to sweep it toward the exhaust. Start with the process, not the fan. Identify the coating and cleaner from their safety data, the application rate, solvent or water content, powder or liquid process, electrostatic equipment, part size, conveyor movement, operator position and curing mode. These inputs define the contaminant, fire and electrical design basis. Next, choose the booth airflow strategy. Crossdraft moves supply air horizontally from the clean side to the exhaust wall. Downdraft moves conditioned air from the ceiling toward a floor or low-level exhaust. Each can work when the booth, part and process are engineered together. Neither layout is automatically correct for every operation. Uniformity is more useful than an average alone. Supply plenums, diffusers, open doors, the vehicle or workpiece, operator movement and blocked filter areas reshape the field. Visualize the entire booth cross-section. Look for reverse flow, dead pockets, and high-speed jets that disturb the coating before it reaches the surface. Overspray must follow a controlled path from the spray zone into the collector without bypassing it. Positioning a large part directly in front of the exhaust can obstruct collection. Baffles and collectors must match the process, remain accessible for cleaning and avoid creating hidden residue pockets. As filters load, pressure loss rises and airflow distribution can change. One overloaded bank can pull the capture field sideways even while the fan remains on. Track differential pressure or the required airflow indication, inspect the whole filter face and define replacement from the applicable booth instructions and process risk. Build the complete resistance path, supply intake, conditioning section, booth opening, plenums, collectors, exhaust duct, treatment equipment and outdoor discharge. Plot clean and loaded system curves against the fan curve. Select the installed duty, motor load and control range, not a free air number from a catalog. Hazard qualification is a separate gate. Do not reduce it to the phrase explosion-proof fan. The coating chemistry, vapor or powder, classified area, fan construction, spark resistance basis, motor and electrical location, grounding, residue compatibility, listing and authority approval must agree. A generic fan image cannot prove that package. Makeup air must replace exhaust without creating door jets or contaminating adjacent work areas. Too little can pull hard through openings, poor distribution can create turbulence across the spray zone. Check booth pressure, building pressure, temperature and interaction with nearby exhaust and combustion equipment. Interlocks should prove ventilation before spray is enabled and stop the process when required airflow is lost. Coordinate fan status, airflow or pressure indication, filter alarm, spray equipment, conveyor, makeup air, fire protection and safe restart. A speed command by itself is not proof that hazardous contaminants are controlled. This is Longwell's airflow test room, shown as measurement context, not a paint booth or spray installation. Commission the actual booth with the intended parts and operating states. Map airflow, observe overspray capture, record clean and loaded pressure, verify alarms and shutdowns, and inspect grounding, residue removal, access and outdoor discharge with qualified specialists. For a project review, send the coating and safety data, liquid or powder process, application rate, part envelope, booth geometry, crossdraft or downdraft concept, required airflow basis, clean and loaded losses, filter and treatment system, duct and discharge, makeup air, electrical classification, interlocks, fire protection, voltage and maintenance access. That evidence turns a fan selection into a defensible spray ventilation system.